Okay, so here's a table, and it's an amusement park raising the price. And we see, let's see, that at first it's adding $5, and then it added $5.50, right? And then it added, what did it add? It added $6.05, right? So what we see is it's not a linear growth, or it's not a growth arithmetically. So now let's take another approach, right? I'm trying to show you the way I would work it out if I didn't know the answer ahead of time, right? Which you don't. So now let's see if they're multiplying by anything. So 50 times what would give me 55, right? Times 1.1, right? 1.1. And then 55 times 1.1. Let's see if that works, right? So if you can't do this, take out your calculator, right, just to see if it works. And 55 times 1.1 is 60.5, so that still worked. And then let's see if it works here. So 60.5 times 1.1, I get 66. So it does work. So this is geometric, right? So describe how prices are growing. They're multiplying by 1.1. Okay. What will the price of admission be in year 6, right? So a couple ways to do this. We could just multiply again for year 6, or we could write a function. So let's say you didn't remember how to write the function, which you should, but let's say you didn't. We could just go and do 4, 5, and 6, right? So I can multiply times 1.1 times 1.1 times 1.1. So let's do that. 66.55 times 1.1 times 1.1 times 1.1, right? And I get 88.58, 88.58. And I could say this is what it would be in year 6, $88.58. Now, if you remember to write the equation, we could write it, right? We could say, f of x, or y, right, equals the 0th term, which is 50, times the multiplier, 1.1, raised to the index, right? So now I could just have said f of 6 equals 50 times 1.1 to the 6th. And I could type that into my calculator, right? 1.1 to the 6th times 50. And I'd get 88.58. So either way, I mean, since it was only the 6th term, just multiplying again isn't a bad idea. But you clearly should know how to write this for a geometric sequence.